All right, we are back. We are going to finish questions 54 through 72 now. Let's go ahead and get our screen up here, and let's fix this screen so that we can see both of them. Oops, forgot to clear this off, so we'll get rid of that. All right, question number 54. Evaluate the expression shown below and write your answer as a fraction in its simplest form. Let's see. Let me go back. 54. Yeah, 53. Okay. All right, 54. We have 1 over 10. Wait, we don't need to do 54. You're supposed to do, no. Hold on, people. All right, we did 52. Okay, so 53 and 54. Y'all are on your own with those. So we're going to start with 55. Okay, there we go. So we're starting on question 55. Perform the operation below. Express your answer as a mixed number in simplest form. All right, so we have 1 3/5 plus 3 1/8. All right, first of all, we need to make them improper fractions. So we're going to say 5 times 1 is 5, plus 3 is 8 over 5. Okay? So 5 times 1 plus 3. Okay? Now we're going to do the same thing. 8 times 3 is 24, plus 1 is 25. So that's 25 over 8. So we have 8 over 5, and we have 25 over 8. Now, we're going to have to figure out a way to make these bottoms the same. And it looks like the smallest number that both of those is going to go into is probably going to be 40. So let's put that right here, and then we'll erase it in a minute. All right, so if we're going to put them over 40, we ran out of room here, but that's okay. All right, 5 times 8 gives you 40, right? So we have to multiply this 8 times 8, which would be 64. All right. 8 times 5 gives you 40. So you're going to have to multiply 25 times 5. Well, if you have 5 quarters, you have 125 cents. All right. And we're adding those up. All right. So we have 64 plus 125. Well, let's add it just because we can. 64 plus 125, 189. All right, so we have 189 over 40 is our answer. All right, so let's remember 189 over 40. Okay, we have 189 over 40. All right, we need to make that back into a mixed number. So how many times will 40 go into 189? Well, 40 times 1 is 40, times 2 is 80, times 3 is 120, times 4 is 160, and times 5 is 200. So 4 is about all we can get out of that. All right? So 160. And then we have 189 minus 160. That leaves us with 29 over 40. All right, so we can check ourselves. 4 times 40 is 160, plus 29 is 189. So 29 is kind of a prime number there, so we're not going to be able to make that any smaller. So we have 4 and 29 40ths. Submit our answer. Say yes. It likes our answer, so we're good. You are going to now work problem 56 and 57 on your own. And when you are ready to join us for 58, go ahead and start your video again. Pause it while you do 56 and 57. All right, question number 58. Perform the operation and reduce the answer fully. All right, so we have 3/5 divided by 9/4. All right, remember our poem. Dividing fractions, don't ask why. Flip the second one over and multiply. All right, multiplying fractions, that's no problem. Top times the top and bottom times the bottom. All right. Now, we have an answer right there, and I will tell you that this one can be reduced because the number 3 will go into both of these. 3 will go into 12 4 times, and 3 will go into 45 15 times. Now, once we get it there, we're not going to be able to get it any smaller. So remember to reduce your answers. All right, and you are now going to work problem 59, which is multiplying. Remember, top times the top and bottom times the bottom, and then reduce it. And number 60, which is dividing. Flip the second one over and multiply, and make sure you reduce your answer fully. Pause the video, and when you are ready to join us for question number 61, turn the video back on. All right. A company orders 29 boxed lunches from a deli for $247.95. If each box lunch costs the same amount, what is the unit cost? Well, we want to know how much they're paying for each lunch. So they spent $247.95, and they were able to buy 29 boxes. All right, so let's use our calculator, or you can divide it out. That's absolutely fine. All right, we have 247.95 divided by 29. That would mean that they are $8.55 for each lunch. So let's go here. I'm going to say 8.55. $8.55 per lunch. That's how much the unit cost is, the unit rate. And there we go. That's all we needed. You are going to work question 62 and question 63 on your own. Pause your video, turn it back on, and join us when you are ready to go to problem number 63. All right. This table shows Braden's earnings on the job. When he worked 11 hours, he made $326.70. Whenever he worked 23 hours, he made $683.10. And when he worked 26 hours, he made $772.20. Now, they pay him the same no matter how many hours he works per hour. They pay him the same amount per hour. So they want to know the constant of proportionality between earnings and time in hours. Well, we could easily take any one of these, and I'll show you all three so that you'll see how it works. All right, $326.70. And we're going to divide that by 11 hours. Wait, that's not right. No, that was right, by 11. All right, so $29.70. So we're going to write that here. Okay, and let's make sure we get the same amount for all of them so that we know that we did this correctly. All right, 683 and 10 cents divided by 23 hours. $29.70 again. All right, let's do it one more time. $772.20 divided by 26 hours. $29.70. So we got the same answer every time, which we should have. So that is how much he makes per hour. All right. Now, you are going to do question 64 and 65 on your own. Remember, if you have questions, there are examples you can look at when you're doing them. All right. After, I think we need to take a look at problem 64. It says, find the equation that represents the proportional relationship for y in terms of x. Okay. Well, let's see. Let's just try one. Let's get rid of this right here. All right. Let's look at your example. I want you to see what an example looks like. All right. So you are going to say y right here, y is 0.7 and x is, all right, well, no, y is 0.4, I'm sorry, and x is 0.7. So here's your x and here's your y. So 0.4 would be your 0.4 right here, your height, that's your y, and then equals k times x, all right, and then you're just going to solve that equation. So let's go back to the original problem. All right, let's use something that's at an intersection right here. Okay, so y would be 3, this point right here. Let's just do an xy. All right, so right here, your y is 3 and your x is 4. All right. And remember we said y equals k times x. All right. So your y, 3 equals k times 4, right? Or 4k. You're going to divide both sides by 4. So you're going to have 3 over 4 equals k. All right. So this is a bonus problem for you guys. 3 over 4. Here we go. We're going to submit your answer. Yeah, it doesn't. Oh, I didn't put the k in it, did I? Oh, guys, I did that all wrong. All right. Y equals 4 over 7x. Yeah, that's what I did wrong. Okay. Let's do that. Oh, it has y. I just put the 3/4. I left out your x. 3 over 4 times x. There we go. Make sure you click right there so that you can put your x there. There. It likes that one better. Yeah. Next time we won't leave that off. So don't forget your x on 65. All right. So technically you only have to do 65 by yourself and then join us when you're ready for problem number 66. All righty. This is another one like you just did. Find the equation that represents the proportional relationship for y in terms of x. Find one that is directly on an intersecting line like this one right here. And since I worked that bonus problem for you, I'm not going to do this one. But I would suggest you use this one right here where your x is 6 and your y is 5. Okay? So that's your point. And remember, it's y equals k times x. 5 equals k times 6. All right, and then you guys finish that out because we already showed you one like that. So you need to do number 67 and number 68 on your own. And then you come back to the video when you are ready to look at problem number 69. All right. The table below shows the number of miles driven is directly proportional to the number of gallons. All right, that he gets the same rate, miles per gallon. He used 46 gallons to drive 2,060 miles. If M represents the number of miles driven for any number of gallons used, write a proportional equation for M in terms of G. Well, all right, so M equals, we can use our K there. So let's use the 50 because let's use 2,240 equals K times 50. All right, so let's get our calculator and clear it out. We're going to say 2,240 divided by 50, 44.8. All right, so 44.8 equals K. All right, that's our constant. And let me take a look here. We want to make sure that, see how they want you to put your answer in. All right, yeah, there we go. All right, let's go back. So M equals 44.8. And let's hope we're just putting it in the right way they want it. Gallons. There we go. It liked the way we put our answer in. All right, now you are going to do questions number 70. Actually, I think we got off a little bit there, and that's all right. 70 is pretty easy. You're just going to find your point here, 0 and -6. Remember, this is your X and this is your Y. I think I'm going to leave you to find that one on your own. So I'll just give you a big hint. Right down here is -6, 0, -6. All right, so our next question, 71 and 72 are both like that. Like I said, it looks to me like I got off on a couple of the numbers there, but you have examples that you can look at. Let's go back. All right, we did problem 69. We probably should have done problem 67. So 68 and 67 are like that. And then 66 we did not do. That's one you needed to do on your own, and 65. All right, 64 we did. Okay, yeah, so we just got off a little here. So you were supposed to do 65 and 66. And instead of doing 67 on this one, we did problem number 69. So you can go back and do those. All right, that is all of the questions on this test. You've had an example of each kind. So you should have plenty of help on here. You got at least one of each type of question answered. So we're going to stop this video now and let you finish what you're doing.